projects for the electrical engineering house project.
The electric company will charge 0.08 kilowatt. Each of these graphs are going to be over the span of a month, but in hours. The total power needed in kilowatts can be modeled with the equation P equals 0.3 minus 0.01 I. The hourly cost over a single month can be modeled over by the equation cost equals 0.02x, and where x is the amount of hours. For example, what would 360 hours cost you? And then you just plug that in the equation and it equals $7.20.
Yeah, I know, but he's got it. Come on, Bailey. Okay.
What is this doing?
It's not changing. There we go. Anyways.
Okay. I'll see. Your second best, the electrical company will charge 0.05 cents per kilowatt plus a monthly service charge of $29. The total amount of power needed in kilowatts can be modeled with the equation 358.24 minus 56.2 times I. The hourly charge for the use of electricity for a single month can be modeled by the equation cost equals 17.9x plus 29, where x is an amount of hours. And then, for example, we also plugged in 360 for that, and once we worked that out, we got 6,473. So per. Yeah.
That's pretty expensive.
It is.
House A, third time's the charm. For this, the electric company will charge about 7 cents per kilowatt plus a monthly service charge of $4. The total amount of power that we got for the equation would be 278.44 minus 78.84 I. And the hourly charge for the use of electricity can be modeled by our equation that we got, which is 19.49x plus 4. And just for the record, the way we got that equation is we multiplied the cents per kilowatt times the constant number in the power, because you're not going to be charged for the heat that's given off, which is going to be the imaginary number. So we only put the constant number after we multiplied it into the equation times the amount of hours plus the monthly service charge, because these graphs are all going to be only in 1 month. It'd be a lot more complex of an equation to do multiple months for this. And we had an example for the amount of hours, like let's say you quit around halfway, which would be around 360 hours. We plugged it into the equation down here and we got $7 grand, $20.40. House D, which is going to be your worst nightmare out of all of them. It would leave you broke completely. And we got electric company will charge you 6 cents per kilowatt plus a monthly service charge of $18. The total power can be modeled by our equation 338.97 minus 89.24 I. The hourly cost equation that we got for that would be 20.3382x plus 18, where x is the amount of hours, of course. And then we got for 360 hours as our example, we got we plugged it into the equation and we got $7,339.75. And the reason why it would be like more than the others, even though it has like a smaller amount of cents per kilowatt, is because each house provides a different amount of power, and based on that amount of power is going to be your cents per kilowatt. So it doesn't matter if you have less cents. If you're using more power, you're going to have a higher bill than the other houses. That's it. Any questions?
Yeah, that was amazing. I appreciate that. It was very, you explained really well about how like the eye was heat and that actually exists as heat. And I know I'm not being charged for that. On those graphs, can you go back to one of those graphs?
Mm-hmm.
Is the eye represented in that graph, or is the heat in that graph?
No, this graph is going to be mainly about the cost for the amount of energy used. As we said with our hourly equation or hourly charge equation kind of thing, we're just using that in the graph to show like what you'd be paying over the span of a month. And you're not going to be paying for the heat like previously stated. So
Okay.
you're only going to be paying for the amount of power you use.
Okay, well, just because I'm kind of interested, this was an amazing presentation. It definitely is very clear. It lets me know what I need to do for our builders. But I'm just curious, just because I don't know the math behind it. I'm curious, will you explain to me, how did you work with eyes with all those equations that you were using? What did you do with eyes in equations?
First, we took the we had to find the R total to kind of do everything for this, which is maybe like the hardest part. We did 1 over R1, which will be the first, I guess you'd call it line of where it's the resistor and the inductor, and that would be the R1 plus 1 over, and then R2, which would be the resistor plus, I think it's the inductor. I think the R1 was the conductor. I'm not sure, but you'd have to rationalize the denominator, and then you'd have to find the common denominator between the two fractions once you rationalized it, and then you'd have 1 over RT, which for our project we had to find the R total, which meant that we had to turn that what?
Right, multiply like the top by the bottom.
Yeah, we had to go through and rationalize the denominator with the 1 over RT. As well as once we had 1 over RT, we could do the power, which is just voltage times current. But the current is just the voltage times 1 over RT. So we just did 1 over RT times voltage to get the power in watts. Then we had to divide all those numbers by 1,000. And to get the power equation, we just went through and divided the top of the fraction by the denominator.
Awesome. I am so glad that I paid the experts to do that instead of do that myself. Thank you guys so much, and we really appreciate your input on which house we should build.